Hello, and welcome to Math Matters. I'm Dr. Jameson, and today we're going to compare circle graphs with bar graphs and identify how they're alike and different. So for this lesson, you will need a paper and a pencil or something else to write with. A calculator would also be helpful. We'll pause for a moment while you gather those materials. Welcome back. Now that you're ready, let's get started. There are a few learning goals for today's lesson. We'll have one math goal and one portrait of a graduate goal. Let's take a look at today's math goal first. I'm learning to compare data represented in a circle graph with the same data represented in a bar graph. By the end of today's lesson, I hope that you'll be able to make connections between data represented in both a circle and a bar graph. Our portrait of a graduate goal is focused on being goal-directed and resilient. Our goal today is around persevering through difficult tasks and situations. That means that you have to keep trying and don't give up, even when things get hard. So let's jump in today's lesson. Let's take a look at these two graphs. Take a moment to think about it. Think about what is the same and what is different. You might have noticed that both graphs are about favorite colors and that 12 people voted in both. You may have also noticed that both graphs have the same amount of each color and that they can be represented as fractions. You may have noticed that graph on the left is a bar graph. Bar graphs are graphs drawn using rectangular bars to show how large each value is. You may also have noticed that this is the exact same data, however, they are displayed in two different graphs. Now, take a look at two more graphs. Take a moment to think about what is the same and what is different between these graphs. You might be noticing that they both have 4 colors, and the colors are the same. You might also have noticed that both graphs are about fruit preferences, and that bananas and apples, pears and strawberries were the fruit that people voted for. You may have noticed that in both graphs, bananas and strawberries each got 15 votes. Or that apples were the most popular fruit in both. You may have noticed that it looks like it could be the same data, just shown in a different type of graph. Let's zoom in and take a closer look at the bar graph. What do you notice about the bar graph? You might have noticed that the scale on the side is counting by fives. You may have also noticed that both the yellow and the red bars are equal. 15. You may have noticed that it looks like only 10 people prefer pears. Or that apples were preferred by the most people. You may also have added up all the bars and notice that 60 people were represented in this data. Now let's zoom into that circle graph. You may notice that both the red and yellow portions each represent 1/4, or 25% of the data in this graph. You may have gone even further and realized that the orange is 2/6, which is equivalent to 1/3 of the data, and that the green is 1/6 of the data. Let's use what we know about fractions, decimals, and percents to figure out how the data represented in the bar graph and circle graph are connected. In the bar graph, 15 out of 60 people, or 15/60ths of the people, prefer bananas. We can simplify 15/60ths by dividing the numerator and denominator by 15, which is the same as dividing by 1 whole to get 1/4, and we know that's equivalent to 25%. So let's take a look at the apple. 20 out of 60 people preferred apples in the bar graph. 20/60ths is equivalent to 1/3. And we know that 1/3 is equivalent to 33/100ths repeating. So 33%. Now let's look at pear. 10 out of 60 people preferred pear in the bar graph. 10/60ths is equivalent to 1/6, which was represented in the circle graph. We know that 1/6 is half of 1/3, or 33/100ths repeating. So that must mean 1/6 is equivalent to 16/100ths repeating, or 16.6% repeating. We can also see that strawberry had the same number of votes as banana, so those values are equivalent. Finally, if we take a look at the totals from each column, we can see that they are all equivalent to one whole or 100%. Let's take a look at this one. Amy thinks that these two graphs show the same data. Spencer thinks they show two different sets of data. Take a moment and look at the graphs. Who do you agree with? We can see the data in both graphs represent people's favorite sports, and that the sports that people voted for were baseball, basketball, soccer, and football. Now let's take a closer look at the fractions that are represented in the bar graph. In order to do that, we need to figure out how many people voted for their favorite sport. We can see that 4 people voted for football. 12 people voted for soccer. 8 people voted for basketball. And 1 person voted for baseball. If we add up all the votes, we can see that 25 people are represented in the data. This means that 4/25 of the votes were for football. 12/25 of the votes were for soccer. And 8/25 of the votes were for basketball. And 1/25 of the votes were for baseball. Now let's look at what this means in terms of percents for each sport. The fractions that were represented on the bar graph are shown in this chart. We can use our calculator to help. Let me think. I'm going to type 4 divided by 25 into my calculator. I'll let you get yours figured out first to figure out the percentage. Let's look at 4/25 first. We know that fractions are another way to represent division. If we divide the numerator by the denominator, we'll get the decimal equivalent and can use that to determine the percentage. I sometimes need to do that as well. So, when I enter 4 divided by 25 into my calculator, I see the decimal equivalent is 0.16 or 16th hundredths. And I know 16th hundredths is equivalent to 16%. Go ahead and use your calculator to figure out what the percent for people voted for soccer, basketball, and baseball. So we did the first one together. See if you can do the next three. Now that you've had time to figure out the rest of the percents, let's revisit the question. Take a moment and decide, who do you agree with? You might have noticed that Amy was in fact correct. Both the bar graph and the circle graph show the same data, just in two different forms. So let's reflect on today's learning. Let's think about our learning goals. In today's episode of Math Matters, we learned about how to make observations and interpret data shown in both a circle graph and a bar graph. How do you feel about your ability to compare the same data represented in two different types of graph? Reflect on how you did working towards these goals today, and give a thumbs up if you got it, a thumb in the middle if you're still practicing, or a thumb down if you feel like you still need a little help from someone or a teacher. I encourage you to share any questions you might have had about today's lesson with your teacher. We had a great time. I'm Dr. Jameson, and I hope you have a mathematical day and keep on counting.